Hello, and welcome to the Computing Conversations column. This column is from the April 2012 issue of IEEE Computer and is titled Discovering JavaScript Object Notation. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan. JavaScript Object Notation, also known as JSON, is a popular format for data serialization. Programmers use it extensively to encode data for transfer between a server and an Ajax application, or to connect two web servers communicating via web services, and in many other similar scenarios. Yahoo's Douglas Crockford is JSON's self-appointed evangelist. He is also involved in the JavaScript community, author of the book JavaScript: The Good Parts from Yahoo Press in 2008, the developer of JSLint, which aims to improve the quality of JavaScript applications. Crockford is careful to point out that he didn't invent JSON, rather he simply discovered it, and told us all about his discovery when I recently spoke with him about JSON, XML, and the future. In a sense, Brendan Eich, profiled in Computer's February issue, invented JSON when he defined the JavaScript language and created a combined serialized literal format for JavaScript values, objects, and arrays. According to Crockford, his innovation was just one in a long history of technically equivalent yet syntactically different natural ways to represent data structures that programming languages use.
The earliest instance I found of JavaScript being used as a data interchange format was at Netscape in 1996. So it's an idea that's been around for a while. And if you look at other data representations, like the property lists that were used at Next and then later at Apple, except for a couple of cosmetic changes, it's the JSON notation as well. So it seems like it's an inevitable sort of representation for data, at least data that is intended to be consumed by programming languages. And ultimately, that's all data.
The most common structures we use in programming are scalar variables, linear lists, and key value pairs. JSON represents these structures in the most natural and direct serialization, greatly reducing the impedance mismatch between in-memory structures and applications and the serialization format. JSON is not only convenient, but it's also efficient. Having JSON parsing built into JavaScript gives it a distinct advantage over other serialization formats such as XML when working with applications partially written in JavaScript. Crockford started using JSON in 2001 when he worked at State Software, a company where he and his colleagues built software demonstrating what would become the JavaScript Ajax pattern. This pattern divided an application's implementation between JavaScript running in the browser and a backend server that housed the data.
I started with JavaScript, but my first application was facilitating communication between programs written in JavaScript and servers written in Java. So I recognized that even though it was born out of JavaScript, it could be and should be language independent. So I simplified it as much as possible, took as much out, tried to make the simplest possible specification for how to structure data and put it on the wire. And that ultimately became called JSON.
In the beginning, JSON was more like a nice feature in JavaScript that happened to make writing these applications much simpler. But in 2001, XML was all the rage in data representation, and potential State Software customers were fearful of adopting anything other than XML. Crockford describes how a typical conversation with a potential customer would transpire.
But we produced some brilliant demonstrations, and we were starting to make some progress in trying to convince potential customers that they should adopt this style of application development. And as part of the description, we'd say, and then we use this JSON idea for communicating the stuff back and forth. And they say, JSON, what's that? And they say, it's this thing we found in JavaScript, and it's really great. And they say, oh, we can't use that. We just committed to XML. So, no, we can't. But XML is wrong for all of these reasons. It's hugely expensive. It's much harder to use all of that. Well, we can't use that thing you did because it's not a standard. We said, it is a standard. It's a proper subset of ECMA 262, which is a standard. They said, no, that's not a standard.
The conversation with potential customers inevitably boiled down to the fact that they found it odd to use JavaScript notation for literal constants as data interchange format. Crockford decided that to address this problem, the idea needed an acronym, a name, and a bit of brand identity, so that people could talk about it and call it something other than that literal constant format from the JavaScript language. As he describes it,
so I decided if I want to be able to use this thing, I need to make it a standard. So I bought JSON.org and put up a web page and sort of declared it's a standard. That's it. That's all I did. I didn't go around trying to convince industry and government and everybody that this is what they should do. I just put up a website, basically a one-page website, and over the years people discovered it and realized, oh yeah, this is so much easier, I'm just going to do that.
If you've worked as a programmer in the past decade, you've witnessed the constant background debate about whether XML or JSON is the right format for data representation. XML was always the well-understood enterprise solution. An extensive toolset was available for working with and manipulating XML. There were sophisticated mechanisms for precisely defining XML schema, and developers could use extensive libraries to create and parse XML. Since the mid-1990s, XML seemed like the safe and logical and obvious choice for data representation in interchange. Industry support for it was broad and well organized, whereas JSON had one web page and one person talking about presentations all around the world talking about this cool idea. So why then is JSON slowly displacing XML as the preferred way to serialize and exchange data? Why is the underdog winning? According to Crockford,
it wasn't that curly braces are so much better than angle brackets. I mean, ultimately none of that matters. The thing that mattered was that the data structures that JSON likes to represent are exactly the same data structures that programming languages represent.
In other words, the point is less about the particular syntax of JSON versus XML, but more that for moving internal structures from one program to another, JSON has a natural advantage as a serialization format. The debate continued when the technique of using JavaScript to retrieve data directly from servers became popular under the moniker Ajax, which stands for Asynchronous JavaScript and XML. The new technique's name incorporated the notion that XML was to be the transport for these new applications. The JSON versus XML dispute flamed anew.
You know, when Ajax was formulated, the X in Ajax was supposed to be for XML. And the smart kids right away realized, well, this is too hard. We don't want to be doing XML here. And some of them discovered, hey, you can use JSON here instead, and it is so much easier, so much faster. So they started doing that. And for a while there was a debate, you know, where some people were arguing, Jesse James Garrett said the X stands for XML, so you can't use anything but XML. That didn't last very long.
Even though JSON seems to be winning as the most natural data transfer representation when communicating from one program to another, developers continue to view XML and HTML as the best representation for document-style information, such as word processing files or web pages. Clearly there isn't a one-size-fits-all solution for data representation, but at least for now, JSON is dominating program-to-program data transfer. Once programmers make the switch to JSON, they seldom switch back to XML for their program-to-program data serialization needs. But inevitably, as more programmers start using JSON, the call for new features, such as the ability to define schema for JSON objects, grows louder. An early example of this trend to add value is the JSON media type for describing the structure and meaning of JSON documents, which Chris Zip put forward as an internet draft request for comments before the Internet Engineering Task Force at www.json-schema.org. The approach in this document doesn't change JSON. Rather, it simply adds some conventions within the existing JSON syntax to define schema details. This ability to add value to JSON without altering it is an essential feature, according to Crockford.
Probably the boldest design decision I made in designing JSON was to not put a version number on it. So there is no mechanism for revising it. So JSON, we're stuck with it. Whatever it is in its current form, that's it. And that turns out to be its best feature. And because it wants to be a low-level thing. I mean, it's basic infrastructure. It's the thing that you pile everything else on. You know, it's sort of the equivalent of alphabet in a language. You know, we might make up lots of words and lots of ways of having sentences, but it's very uncommon to make up new letters. And that's sort of the place where JSON lives. So it's good that it's not going to change.
Another effort that adds value to JSON without changing it is JSON for linked data at www.json-ld.org, which adds simple extensions to JSON so it can easily represent large linked data structures typically represented via RDF. Like the JSON media type, JSON-LD is an extension that works without changing the JSON structure. In a sense, JSON LD is just another language using JSON as its alphabet. JSON is moving from being an underground secret, known and used by very few, to becoming the clear choice for mainstream data applications. But perhaps what's most exciting is its value-add capabilities that will become a part of the developer's toolkit as JSON increasingly takes over the heavy lifting of data encoding and interchange. This column is from the April 2012 issue of IEEE Computer and is titled Discovering JavaScript Object Notation. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I am the editor of the column, and I'm Charles Severance from the University of Michigan.